Section 10.3, Functions with Spring Cloud Function. Oleg Zhurakowski, project lead for Spring Cloud Function and Spring Cloud Stream, often asks conference audiences this question. Is there any business feature that you cannot define in terms of suppliers, functions, and consumers? It's an interesting and challenging question. Can you think of anything? Most software requirements can be expressed with functions. Why use functions in the first place? They are a simple, uniform, and portable programming model that is a perfect fit for event-driven architectures, inherently based on these concepts. Spring Cloud Function promotes the implementation of business logic via functions based on the standard interfaces introduced by Java 8, supplier, function, and consumer. Supplier. A supplier is a function with only output, no input. It's also known as a producer, publisher, or source. Function. A function has both input and output. It's also known as a processor. Consumer. A consumer is a function with input but no output. It's also known as a subscriber or sink. In this section, you'll learn how Spring Cloud Function works and how to implement business logic via functions. Section 10.3.1, Using the Functional Paradigm in Spring Cloud Function. Let's get started with functions by considering the business requirements I listed earlier for the dispatcher service application. Whenever an order is accepted, dispatcher service should be responsible for packing and labeling the order and for notifying interested parties, in this case the order service, once the order has been dispatched. For simplicity, let's assume that both the pack and label actions are performed by the application itself, and we'll consider how to implement the business logic via functions before even thinking about frameworks. The two actions to be performed as part of dispatching an order could be represented as functions. The pack function takes the identifier of an accepted order as input, packs the order, in the example the processing is represented by a log message, and returns the order identifier as output, ready to be labeled. The label function takes the identifier of a packed order as input, labels the order, in the example the processing is represented by a log message, and returns the order identifier as output, completing the dispatch. The composition of these two functions in sequence gives the full implementation of the business logic for dispatcher service, as shown in Figure 10.6.
Figure 10.6. The business logic for dispatcher service is implemented as a composition of two functions, pack and label.
Let's see how we can implement these functions and what Spring Cloud Function brings to the table. Initializing a Spring Cloud Function project. You can initialize the dispatcher service project from Spring Initializer, start.spring.io, and store the result in a new dispatcher service Git repository. The parameters for the initialization are shown in Figure 10.7.
Figure 10.7. The parameters for initializing the dispatcher service project.
Tip. In the Begin folder for this chapter, you can find a curl command that you can run in a terminal window. It downloads a zip file containing all the code you need to get started without going through the manual generation on the Spring Initializer website. The resulting dependencies section of the build.gradle file looks like this.
See this code?
The main dependencies are Spring Boot, org.springframework.boot Spring Boot Starter. Provides basic Spring Boot libraries and auto-configuration. Spring Cloud Function, org.springframework.cloud Spring Cloud Function context. Provides the Spring Cloud Function libraries that promote and support business logic implementation via functions. Spring Boot Test, org.springframework.boot Spring Boot Starter Test. Provides several libraries and utilities for testing applications, including SpringTest, JUnit, AssertJ, and Mockito. It's automatically included in every Spring Boot project. Next, rename the auto-generated application.properties file to application.yml and configure the server port and application name. At present, the application doesn't contain a web server. Nevertheless, we'll configure the server port number because it will be used when we add monitoring capabilities to the application in Chapter 13.
Listing 10.3. Configuring server and application name.
Next, let's see how we can implement the business logic using functions. Implementing the business logic via functions. The business logic can be implemented in a standard way by using the Java function interface. no Spring needed. Let's first consider the pack function. The input of the function should provide the identifier of an order that has previously been accepted. We can model this data via a simple DTO. In the com.polarbookshop.dispatcher service package, create an order accepted message record to hold the order identifier.
Listing 10.4. A DTO representing the event about orders being accepted.
Note: modeling events is a fascinating topic that goes beyond Spring and would require a few chapters to cover properly. If you'd like to learn more about this subject, I recommend reading these articles by Martin Fowler, Focusing on Events, see this link, Domain Event, see this link, and What Do You Mean by Event-Driven, see this link, all on his martinfowler.com blog. The output of the function can be the simple identifier of the packed order represented as a long object. Now that input and output are clear, it's time to define the function. Create a new dispatching functions class and add a pack method to implement order packing as a function.
Listing 10.5. Implementing the pack action as a function.
You can see how there's only standard Java code in this listing. I strive to provide real-world examples in this book, so you might wonder what's happening here. In this case, I decided to focus on the essential aspects of using the functional programming paradigm in the context of an event-driven application. Inside the function, you can add any processing logic you like. What matters here is the contract provided by the function, its signature, inputs, and outputs. After defining that, you're free to implement the function as needed. I could have provided a more real-world implementation of this function, but it would have added nothing valuable considering the goal of this chapter. It doesn't even have to be Spring-based code. And in this example, it's not, it's plain Java code. Spring Cloud Function is capable of managing functions defined in different ways, as long as they adhere to the standard Java interfaces function, supplier, and consumer. You can make Spring Cloud Function aware of your functions by registering them as beans. Go ahead and do that for the pack function by annotating the dispatching functions class as configuration and the method as bean.
Listing 10.6. Configuring the function as a bean.
As you'll see later, functions registered as beans are enhanced with extra features by the Spring Cloud Function framework. The beauty of this is that the business logic itself is not aware of the surrounding framework. You can evolve it independently and test it without being concerned about framework-related issues. Using imperative and reactive functions. Spring Cloud Function supports both imperative and reactive code, so you're free to implement functions using reactive APIs like Mono and Flux. You can also mix and match. For the sake of the example, let's implement the label function using Project Reactor. The input of the function will be the identifier of an order that has been packed, represented as a long object. The output of the function will be the identifier of the order that has been labeled, resulting in the dispatching process being complete. We can model such data via a simple DTO, just like we did for order accepted message. In the com.polarbookshop.dispatcher service package, create an order dispatched message record to hold the identifier for a dispatched order.
Listing 10.7. A DTO representing the event about orders being dispatched.
Now that the input and output are clear, it's time to define the function. Open the dispatching functions class and add a label method to implement the order labeling as a function. Since we want it to be reactive, both input and output are wrapped in a Flux publisher.
Listing 10.8. Implementing the label action as a function.
We have just implemented both functions, so let's see how we can combine and use them. Section 10.3.2. Composing and integrating functions, REST, serverless data streams. The implementation of the business logic for dispatcher service is almost done. We still need a way to compose the two functions. Based upon our requirements, dispatching an order consists of two steps to be executed in sequence: pack first and label after. Java provides features to compose function objects in sequence using the and then or compose operators. The problem is that you can use them only when the output type of the first function is the same as the second function's input. Spring Cloud Function provides a solution to that problem and lets you compose functions seamlessly through transparent type conversion, even between imperative and reactive functions like those we defined earlier. Composing functions with Spring Cloud is as simple as defining a property in your application.yml or application.properties file. Open the application.yml file in your dispatcher service project and configure Spring Cloud function to manage and compose the pack and label functions as follows.
Listing 10.9. Declaring the functions managed by Spring Cloud.
The Spring.Cloud.Function.Definition property lets you declare which functions you want Spring Cloud function to manage and integrate, resulting in a specific data flow. In the previous section, we implemented the basic pack and label functions. Now we can instruct Spring Cloud function to use them as building blocks and produce a new function that comes from the composition of those two. In a serverless application like those meant to be deployed on a fast platform, such as AWS Lambda, Azure Functions, Google Cloud Functions, or native, you would usually have one function defined per application. The cloud function definition can be mapped one-to-one to a function declared in your application, or you can use the pipe, vertical bar, operator to compose functions together in a data flow. If you need to define multiple functions, you can use the semicolon character as the separator instead of the pipe, vertical bar. To sum up, you only need to implement standard Java functions, and you can then configure Spring Cloud function to use them as they are or after combining them. The framework will do the rest, including transparently converting input and output types to make the composition possible. Figure 10.8 illustrates the function composition.
Figure 10.8. You can combine functions with different input and output types and mix imperative and reactive types as well. Spring Cloud function will transparently handle any type conversion.
At this point, you're probably wondering how you can use these functions. That's my favorite part. Once you define the functions, the framework can expose them in different ways depending on your needs. For example, Spring Cloud function can automatically expose the functions defined in Spring.Cloud.Function.Definition as REST endpoints. Then you can directly package the application, deploy it on a fast platform like Knative, and voila, you've got your first serverless Spring Boot application. That's what we'll do in Chapter 16 when we build serverless applications. Or you can use one of the adapters provided by the framework to package the application and deploy it on AWS Lambda, Azure Functions, or Google Cloud Functions. Or you can combine it with Spring Cloud Stream and bind the function to message channels in an event broker like RabbitMQ or Kafka. Before we explore the integration with RabbitMQ using Spring Cloud Stream, I want to show you how to test the functions and their composition in isolation. Once the business logic is implemented as functions and tested, we can be sure it will work the same way, whether it's triggered by a REST endpoint or an event notification. Section 10.3.3. Writing integration tests with functional Spring Boot test. Using the functional programming paradigm, we can implement business logic in standard Java and write unit tests with Unit without being affected by the framework. At that level, there is no Spring code, just plain Java. Once you've ensured that each function works, you'll want to write some integration tests to verify your application's overall behavior when your functions are processed by Spring Cloud function and expose the way you configured. Spring Cloud function provides a functional Spring Boot test annotation you can use to set up the context for your integration tests. Unlike unit tests, you don't want to invoke the function directly, but rather ask the framework to provide that for you. All the functions managed by the framework are available through the function catalog, an object that acts as a function registry. When the framework serves the function, it doesn't only contain the implementation you wrote, it's enhanced with extra features offered by Spring Cloud function, like transparent type conversion and function composition. Let's see how this works. First, you need to add a test dependency on Reactor test in the build.gradle file, since part of the business logic is implemented using Reactor. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 10.10. Adding dependency for Reactor test in dispatcher service.
Then, in the src/test/java folder of your dispatcher service project, create a new dispatching functions integration tests class. You can write integration tests for the two functions individually, but it's more interesting verifying the behavior of the composed function, pack plus label, as provided by Spring Cloud function.
Listing 10.11. Integration tests for a function composition.
Finally, Open a terminal window, navigate to the Dispatcher Service Project root folder, and run the tests.
See this code?
This type of integration test ensures the correct behavior of the defined cloud function, independently of how it will be exposed. In the source code accompanying the book, you'll find a broader set of autotests, Chapter 10/10, Intermediate/Dispatcher Service. Functions are a simple yet effective way to implement business logic and delegate infrastructural concerns to the framework. In the next section, you'll learn how to bind functions to message channels on RabbitMQ using Spring Cloud Stream.